Hi, these are the notes for the Amphibian Introduction. This is the first set of notes for Unit 6, Amphibians and Reptiles. In this lesson I'll discuss the evolution of amphibians from fish, how different amphibians will metamorphosize, that really defining characteristic, how that helps us to discuss the classification of what kinds of amphibians we have, and then amphibians' place in ecosystems and threats they face today. So, to look at amphibians in evolution, they are this double life organism, and that's what the word amphibian means. It means dual life, and that's water and land. And fish are all water. Reptiles, mammals, birds, they're all land. So amphibians are this transitional state of organisms, this living record of the jump from organisms in the water to organisms on land. And we can see fish today that still do have a transitional kind of attitude. They, like these mud skippers here, they can live in water, they can live on land. They have these swim bladders that they gulp air to use for breathing. They have strong fins that hold them up, and really adaptations that will allow them to survive on land. But we've seen the evolution of fish, of how they've evolved from those tiny sac-like sea squirts to the development of the vertebrae that led to other structures, full skeleton, and the fins. And it was this lobe-finned fish that we really think gave us the direction to terrestrial tetrapods, four-legged organisms on land. The Rayfin fish is mostly what you see today, but they're all pretty much still in water. So it was thought for a long time that lobe-finned fish were extinct, and we only really saw fossils of them, but it turns out the coelacanth still exists today. It's very rare, but still found in some places. They have very different fins. You may think like a carp or a bass and how they have that ray fin, bony design. Well, lobe-finned fish have a lot of bones and this whole lobe that sticks out before you start seeing the rest of the fin, which provides an opportunity for a growth of some sort of limb, an extension of those bones. And if we were to think, what kind of organism in the fossil record would be very much like a fish, but also very much like an amphibian, what we would call a transitional fossil. And we found this guy, his name is Tiktaalik, and he shares a lot of those fish and amphibian traits. He has fins, but he also has limbs that he can use with wrists to help prop himself up. He's got this alligator-like head with the nostrils and the eyes up top. So he is very well adapted to not only life in the water, but life on land. So our ancestral amphibians here, we see, are sharing a lot of the same bones in those limbs as they are to the lobe-finned fish. Whether it's the radius and the ulna and the tibia, so you've got the one bone, two bones, and then many bones that make up the hand. And it's the same in these lobe-finned fish. They've got the one bone femur, two bones, radius and ulna in the forearm, and then many bones that make up the fin part. Now, amphibians today will do the very recognizable action of metamorphosis, this really big change from early larval stage to adult stage. And their changes really represent what's useful for water and what's useful for land. So in the water they have the tail and the gills. Their tail is very much like a fin, but they can live in the water, and then as they metamorphosize, they are going to be adapted to the land. They gain the limbs, they gain the lungs, and this is very apparent in the frogs, who also, they lose their tails. They all breathe with lungs in the adult stage. But salamanders actually have multiple different kinds of metamorphosis. Some of them develop lungs, some of them keep their gills and stay in the water. Some of them do a little bit of both, and many of them just end up breathing through their skin, but they have to stay in these moist environments. And that's true for all amphibians. They are tied to water throughout their life, but they are now more adapted in their adult stages to be further from the water. But everybody has to go back to the water to at least reproduce. So that gives us our two different orders. So we're in the kingdom on Animalia, animals. We are in the phylum Chordata, anything with a backbone. We are in the class Amphibia, so these are all of our amphibians. It's not the class Reptilia or the class Mammalia, it's the class Amphibia. And we have two main orders, which are our frogs and toads, Anura, and salamanders, Urodela. There's also caecilians, which aren't found in North Carolina. Amphibians have a special place in the ecosystems, but it depends on their stage. The larvae, as they're in the water, they're going to have a different place in an ecosystem. They are going to be eating algae, plants, and tiny little microinvertebrates. So they'll eat whatever they can get their mouth around. But the adults are going to be much more predatory on larger organisms, be it grasshoppers or maybe even small mammals if it's a large enough organism. And then, of course, they are going to be food for many terrestrial animals at that point. Their skin is very permeable, and that helps some of them breathe. It helps them stay moist. They are attached to the water throughout their life. They need to stay moist, but this permeable skin also makes them very susceptible to environmental issues like pollution, acid rain, metals in the water or the soil. So anything they come into contact with, they're going to absorb it through their skin. That makes them very susceptible to pollution, and it also makes them a good indicator species, meaning if something's wrong with the amphibians, then something is wrong with the environment. So there could be a problem for other wildlife as well as a problem for us. And we are seeing amphibians decline throughout the world in all different continents, namely in the tropics. So they are classified as either frogs and toads or salamanders. They evolved from fish to adapt to terrestrial life. They still metamorphosize, where they are going to share the aquatic characteristics early in life, but terrestrial characteristics later in life. And they are an important connection between many things in the food webs, as well as a good indicator for any environmental threats.